Hi, hello. This is Lab 1 for Constant Velocity by Kevin Rosas. So in today's video, I'll introduce the main concepts for the lab, followed by the experiment, the principles, the code, then the models, the discussion questions, and then finally the conclusion. So the main purpose of this lab is to observe the motion of an object at a constant velocity and compare the practical results to the theoretical values. So we find that uniform motion occurs when there's constant velocity in a single direction, which means that there's no acceleration occurring. The fundamental physical principles that support this statement is Newton's first law of motion and the position time graph. So for this experiment, we gave an expo marker an initial force in the positive x direction, and we see that it is traveling at what seems to be a constant speed. We calibrated the distance first by using a meter stick within our video. The system we said was the expo marker, and the universe around it is the table in which it is rolling. We said that the position vector for the expo marker started at position 0, 0, 0, and we later calculated the speed by taking the position and time at two different instances and finding the average among them using the average velocity equation. So the main principles present within the experiment is Newton's first law, which states that an object at rest will stay at rest unless acted upon by a net force. And so since the speed of the object is not changing, it should theoretically have uniform motion, since the net forces acting on the expo marker sum to zero, as shown in the position time graph. And so this graph showcases that the slope of a position time graph is constant, which means that the position is changing at the same rate. And in terms of the glow script code, I changed the velocity of the ball to 0.3125 meters per second in the x direction, since the only force that was acted upon by the expo marker was in the x direction. And this is what we used to later find the update for the position. And I changed delta t down here based on the difference between the two time instances that I used to calculate velocity. So I changed net force to zero in this case because Newton's first law states that if you remain in constant motion, then your net force should be zero. And so this is the velocity update formula and the position update formula. And so since net force is zero, the velocity update formula tells us that the velocity should not change and that the position update formula is taken relative to velocity. So what this means is that since velocity is the same, we should see the position being updated at the same rate for each time interval. And so here on the left-hand side, we see that the two graphs that GlowScript actually provided for me when I ran the code. So, and then here is the graph that Tracker provided for me once I took all the data points and plotted them into a graph. And so once we combine the position versus time graph from GlowScript and the position time graph from Tracker, we get this graph on the left-hand side. And so we see that the actual graph that we took from the experiment actually deviates from the theoretical at a certain point. And so some reasons why this happened was because of frictional forces between the expo marker and the table and potential human error when plotting the actual points. And so what would happen if we flip the axis? So magnitude should remain the same because speed remains the same. Nothing was changed about speed. The only thing that did change was the direction of the vector. So the new vector should be negative as the vector was flipped, and it is going in a different direction, but it still has the same speed. And how many forces were in the system? We said that it would be gravity, friction, normal forces, and potentially some rolling force that we do not know of yet. And in terms of the conclusion, we observed the motion of a constant velocity object. We compared the practical results with the theoretical results. And at constant velocity, the net forces applied to the object are zero, which means that the acceleration is zero. And some potential sources of error is tracking using human input will never be precise or accurate, and forces that we did not consider within the experiment.